Okay, so let's go to our demonstration. So what I'm going to do here is that I'm going to run AFL from the Docker, as you can see here. And then here you're going to see that in the Docker, I have all the AFL things. I'm going to create one code here. As you can see here, it's basically a code full of if-then else's, and then we have to explore this code. The code reads three variables, traverses, then if, then else, and then returns, prints a value in the end. So what you have to do is that we have to compile with AFL, because as I told you, AFL, this is white box fuzzing, AFL is going to prepare the binary for fuzzing. So AFL is going to take my input.c and prepare the input.bin as normal. So you can see it instrumented the binary, but the binary keeps working. So if I run the binary, I can still give a number to the binary. It's still, oops, sorry, I run it wrong. And it's going to give me a number. Depending on the values that I put here, it gives a different number. And depending on the value that I will put, this code might eventually crash, right? So this, depending on the value that we put here, there is a crash hidden inside the binary. So one way to do that is, for instance, to put a value 250 instead of this one, 250, and then you can see there is a division by 0 here. So it's just a crash, not a security vulnerability, right? And if I put other values, as I saw, if I put 25 and 1, then there is no division by 0. That's why we have to mutate just a little bit, because it's in general in the corner, right? From 0 to 1, it's a subtle difference, but it's the difference between having a crash or not, right? So that's what we should do. But once we are ready to do that, we can run the fuzzing thing. So what we have to do is we need to create like an input for seeds. Let's create one for results as well, right? Called seeds. And then you're going to have the results. And in the seeds, we can put multiple seeds, as I said, but I'm going to put like input 1, and then input 1 will be simply like 1, 2, 3. That is a valid input, right? So you're going to start running AFL from 1 to 3, and then it's going to mutate this automatically. So we can simply run AFL to test the application automatically for us. So we are going to say LFL to fuzz. The seeds are coming from the seeds. The results are going in the results. The application that I want to run is the input.bin. So if I do this, the fuzzing process should start. As you can see, the fuzzing process is running. So it's going to run for a while. The fuzzer is going to control this for me. It's using already all CPUs in this machine. It's going to control everything in parallel, mutating the seeds, controlling the coverage. All this information are displayed here. You can see how much it's covering, and then it's going to find how much crashes and how much things are found. So we can see here, so it's running for this time. In this case, it's running for less than a minute. In general, we fuzz for long time, hours. If we have a cluster, weeks, like Google fuzz its projects for weeks. Google Chrome is fuzzed by weeks and months in a big cluster, because they want to really exercise the entire application, right? So we can see other information. For instance, it already found a crash, right? So you have a crash here, right? What else we have? So we have densities, how much in depth we are going. As I said, it controls the controls the coverage of the application, right? What else? And about the strategy, how much mutation it did. So you can see if it did bit flips, it did arithmetic things, what kind of operations it's doing, right? So basically, it's telling here what type of things they are doing and how many of them are crashes or not. So you have all the statistics. It keeps running. We can keep running for a while, right? I don't have all the time here to leave it running, so I'm going to stop here, and I'm going to show you that we have here a directory inside the results called crashes. Oops, default crashes. And inside the crashes, we have these crazy things here. That is the crash file, as I mentioned. The crash file looks something like this. So it's giving an invalid input to the application. So it started from the number, as I said, and you can see it did a small modification because the 123 become 1230p. And then, as you know, when we pass, this will be treated as an integer, this will be treated as the second integer, 0 will be treated as the third integer. And when you have 0 as the third integer, what happens is that the application crashes. And then you can see this in practice, because if I say input.bin, it's provided with the crash given by the fuzzer, what happens is that we found that floating point exception that we are looking for since the beginning, right? So the fuzzer worked, right? So you can do this in your project to test your own applications, and to practice, you can do this in the assignment. So for the assignment, the idea is to once again reproduce what I'm doing, creating your own application that has one or more vulnerabilities. The more vulnerabilities, the better, because the fuzzer has a greater chance to find one of them. Get the AFL, for instance, from the Docker, put it to run in your own application, and show your application being fuzzed, show the fuzzer found crashes, and show, as I did, the crash actually being run against your application and crashing your application. Yeah, as I did. That's what we have for today. Thank you. See you in the next class.